Hello dear students, how are you? Today we will discuss atom. Atom is the smallest particle of matter. First of all, we will discuss model of an atom. An atom consists of a positively charged sphere and the electrons are embedded in it same way as in watermelon. Red part is positive charge and seeds were considered as electrons negative charge. The negative and positive charge are equal in magnitude, so the atom as a whole is neutral. Rutherford model of an atom. Ernest Rutherford was interested in knowing how the electrons are arranged within an atom, so he performed an experiment for this. In this experiment, fast moving alpha particles were made to fall on a thin gold foil. He selected a gold foil because he wanted as thin a layer as possible. Alpha particles are doubly charged helium ions. Since they have a mass of 4 units, the fast moving alpha particles have a considerable amount of energy. It was expected that alpha particle would be deflected by the subatomic particles in the gold atoms. Since the alpha particles were much heavier than the protons, he did not expect to see large deflection. After the experiment, it was unexpected results. The following observations were made. Most of the fast moving alpha particles passed straight through the gold foil. Some of the alpha particles were deflected by the foil by small angles. Surprisingly, 1 out of every 12,000 particles appeared to rebound. Rutherford concluded from the alpha particle scattering experiment that most of the space inside the atom is empty because most of the alpha particles passed through without getting deflected. Very few particles were deflected from their path, indicating that the positive charge of an atom occupies very little space. A very small fraction of alpha particles were deflected by 180 degree, indicating that the all positive charge and masses of the old atoms were concentrated in a very small volume within the atom. On the basis of his experiment, Rutherford put forward the nuclear model of an atom. There is a positive charge center in an atom called the nucleus. Nearly all the mass of an atom resides in the nucleus. The electrons revolve around the nucleus in circular paths. The size of the nucleus is very small as compared to the size of the atom. Drawbacks of Rutherford model of the atom. The revolution of the electrons in a circular orbit is not expected to be stable. Any particles in a circular orbit would undergo acceleration. During acceleration, charged particle would radiate energy. Thus, the revolving electrons would lose energy and finally fall into the nucleus. If this were so, the atoms would be highly unstable and hence matter would not exist in the form that we know. In order to overcome the objection raised against the Rutherford model of the atom, Niels Bohr put forward the following postulates about the model of an atom. Only certain special orbits known as discrete orbits of electrons are allowed inside the atom. While revolving in discrete orbit, the electrons do not radiate energy. These orbits or cells are called energy level. Energy level in an atom are shown here. These orbits or cells are represented by the letter K, L, M, N or the number 1, 2, 3, 4. The following rules are followed by writing the number of electrons in different energy level or cells. The maximum number of electrons present in a cell is given by the formula 2n square, where n is the orbit number or energy level. So we can find out K may have 2 electrons and L maximum 8, M maximum 18 and N maximum 32. The maximum number of electrons that can be accommodated in the outermost orbit is 8. Here you can see the electronic configuration of many elements. You can see outermost orbits have a few electrons. So the electrons present in outermost orbits are called its valency, or required to complete its outermost orbit's electrons number is also called its valency. Atomic number. The atomic number is defined as the total number of protons present in the nucleus of an atom. Total number of proton and total number of electron is always same. That's why the atom is neutral. Mass number. The mass number is defined as the sum of the total number of proton and neutron present in the nucleus of an atom. Isotopes. Isotopes are defined as the atom of the same elements having the same atomic number but different mass number. Examples of hydrogen isotopes are protium, deuterium, and tritium. Isobars, atoms of different elements with different atomic number which have the same mass numbers are known as isobars. For example, calcium atomic number is 20 and the argon atomic number is 18. Different atomic number, but they have the mass number 40. Same. Applications and uses of isotopes. An isotope of uranium is used as a fuel in nuclear reaction. An isotope of cobalt is used in the treatment of cancer. An isotope of iodine is used in the treatment of goiter.